Welcome to our next lesson in Level 2 Mechanics, velocity. So for understanding velocity, we first have to have an understanding of motion. So what is motion? Well, basically motion is an object's change in position relative to a reference point. Okay, that's known as displacement. So here's a spaceman out on the edge of our atmosphere. So relative to the Earth, the astronaut is moving at 28,000 kilometers an hour, but relative to the space shuttle he's right next against, he is not moving. So remember, it's a change in position relative to a reference point. In this case, we have two reference points, the Earth and the space shuttle. So in terms of displacement, there is constant displacement. Okay, so it can be illustrated on two different graphs. The distance time graph, where the distance is a constant over time, and in terms of its position from a reference point, the velocity, which is displacement over time, is going to be also constant, but in this case the displacement will be zero. It's not moving from its reference point. So this is the difference between average speed and velocity. So average speed is the total distance traveled divided by total time, whereas average velocity is the total displacement divided by total time. So in terms of constant positive velocity, what you will see is that for a distance time graph, it is traveling a certain distance over a certain amount of time. It's constant, that change in distance over time. So you'll see a straight line relationship, as you see in the video. Whereas in terms of velocity, it's going to be a constant. Okay, it's going to be a constant displacement over time from that reference point. Okay, so basically it's the changing position at a constant rate forward. And you also have constant negative velocity, which will have a negative gradient for distance time graph, but in terms of velocity, it will be a negative constant velocity. Okay, and that's what you see on the second graph. So in terms of plotting displacement versus time, which one of these runners, A, B, or C, will be running fastest? It will be runner A, because the gradient, the change in distance over the change in time, is greatest for runner A. Change in distance over change in time, rise over run. So this is the power actually of the gradient or slope. So you can use the slope in the distance time graph, which will give the velocity, to use that in the velocity time graph, where we will explore the change in velocity over change in time, or acceleration. And that will be another lesson.